everybody, and welcome to section 5.4. This is about the triangle inequalities. We have theorem 5.11 here, triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I have any two sides of a triangle, they will add up and be greater than the length of the third side that you didn't include. So AB and BC, that must be greater than AC. BC and AC in this picture must be greater than AB. AC plus AB must be greater than BC, and that is true for all triangles. So let's look at a couple examples and see how this works. We're going to determine whether or not the three sides form a triangle. So if I have a side 3, 5, and 9 in measurement, we'll go through and check. Any two must be greater than the third. So if you look at 3 and 9 added together, that gives you 12. 12 is greater than 5. That works. 5 plus 9. That added together gives you 14. 14 is definitely greater than 3, so that works. However, 3 and 5 added together, that gives you 8. It is not greater than 9. So these three sides would not be a triangle. It just wouldn't work. 8, 10, and 12. 10 and 8 make 18. 18 is greater than 12. 8 and 12 are 20, greater than 10, yes. 12 and 10, 22 is greater than 8. So yes, these three form the side of a triangle, because they satisfy the triangle inequality theorem. A couple more theorems to give you. Theorem 5.12, the perpendicular segment from a point to a line is the shortest segment from the point to the line. So the shortest segment is going to be perpendicular, so segment PQ is the shortest segment from point P to line AB. It's always perpendicular. We have these other segments here, these other lines that can be drawn, but the shortest one is always perpendicular. Corollary to this is the perpendicular segment from a point to a plane is the shortest segment from that point to a plane. So even though, this picture talked about the distance from a point to a line, the same holds true from a point to a plane.